Okay guys, so as you can see here, we're going to be doing factoring. It's going to be big in this next unit, and honestly the rest of the year in Algebra 2. You did do this back in Algebra 1. You did it a lot actually. So just quickly going through these rules, and we'll practice it a bit more daily, but this is kind of one of those skills that we expect you to retain from Algebra 1, so we'll keep you, updated on it. Remember, these are trinomials, so when you do it, you want to come up with, when the a value is 1, there's not a number in front, two numbers that'll add to this and multiply to that. The only two factors that will add to that number in the middle and multiply to that are positive 4 and positive 1. So in factored form, you would write it as m plus 1 and m plus 4. And remember, if you were to FOIL or box and multiply that out, you would come up with that trinomial, m squared plus 5m plus 4. Even here, what's two numbers? Okay, again, it starts with a 1. Add to this and multiply to that. The only numbers I can think of are 8 and 8. But in order to add to a negative 16 and multiply to a positive 64, both 8s should be negative, and we show it like that in the parentheses. Okay. Here, now this is one of the special ones. I would put a little star. This is the difference of squares. So the rule is, if it's difference, which is subtraction, and you have two perfect squares, which we do, because the square root of x to the second power is x, and the square root of 121 is 11, the rule is you make one a plus and the other a minus. Okay? Number 4 here. Here, x squared plus 64. This, I understand, this is a perfect square and so is that, but this is a plus. And when you see this, we call this prime. Like a prime number, you can't divide it out, you can't nothing. You just leave it there, that's your answer. You would just write prime. There's no factors for it. Okay, number 5 and 6, we do it a little differently in Algebra 2. I'm pretty sure Algebra 1 taught you something similar. You're still looking for numbers that'll add to 5, but you can't multiply to 12. That doesn't make any sense. So here what we do is this thing called like the T method. So what you do is we put numbers that multiply to 3 here, so we think factors of 3 are 1 times 3, go across here, or downward. Then numbers that'll multiply to 12. Now obviously we know there's 2 and 6, 4 and 3, so it's kind of guess and check and like kind of going in and seeing what you can do. So let's try 4 and 3. And here's how we check it. It has to add to 5. So diagonally, imagine you're reversing the FOIL. 3 times 4 is 12. 1 times 3 is 3. Is there any way 12 and 3 will add to 5? No. So that can't be our set. Let's switch it around. Let me try the 3 here and the 4 here. So 3 times 3 is 9. 1 times 4 is 4. Yes, they will add to a positive 5, okay, as long as the 4 is negative and the 9 is positive. So when you rewrite your answer, since the 9 came from the 3 times 3, I'm going to put a plus in front of here and a minus in front of the 4. And then you attach the variable of x always on the left column. And you put your parentheses for your factors straight across. So my two factors are 1x plus 3 and then 3x minus 4. Those are my two factors. Here, if you take a look here, same thing. This is a number in front, no GCF, so I'm going to jump to the T-chart. Numbers that multiply to 2 are 1 and 2, and then the only numbers that multiply to 7 are 7 and 1. And again, we still want this process to add to 15 because that would be the middle numbers when you FOIL. So let's go across. 2 times 7 is 14. 1 times 1 is 1. They will clearly add to 15 as long as they are both positive numbers, right? 14 plus 1. So I'm going to put a little plus here and a plus here and put an x. And then my answer are x plus 7 and 2x plus 1. So I'll be posting some factoring videos on the Google Classroom, to kind of get you back in the groove, and we'll periodically do this. Probably in another class or so, guys, we're going to do a graded classwork so I can just see who knows what or how much you know, kind of like a pre-assessment on factoring. Now, what you're going to be doing today in class is you will be grabbing a laptop and you guys will be logging in to Gizmos. Okay? It tells you what to type in, you're going to click enroll in a class, and this is the code on the paper that you're going to be getting right away. It's going to say enroll in a class, teacher code. You type that in exactly like that. And then if you have not signed up for a Gizmos account, you click where it says I have not signed up, and it's going to ask for information. Okay? You don't have to put in your email account, but I need first name, last name, stuff like that. Then it'll ask the username and password, and keep this sheet because we're going to use Gizmos, quite a bit in here, so that way you don't lose your password and your name. Once you go in there, you're going to see 3 different student explorations that you're going to be completing. I have printed out a hard copy of what I want you to be doing. So you're going to hit Launch Gizmos. Your goal today is to do all 3 of these, okay? Online, on the laptop, 1, 2, 3. Doesn't really matter what order. You make that call, but you are to enroll first. Then, once you enroll successfully, it will have the 3 gizmos. You click Launch on one of them, and each of these goes through and asks questions. So it tells you to drag the K, do this, type in that number. That's your objective today. We're starting our new unit on quadratics. It is nothing new. It's from Algebra 1, and this is going to help you back and explore what you've already learned. Hopefully to ring a bell and, get you some memories. So that's your goal. Okay? Good luck.